Kia ora, everybody, and good morning. As Susie says, lots of people have contributed to the study. She's listed them all. I've only put up there the names of those who have got an ego. I'm going to go backwards. Hugh's already touched on many of these elements, but I'm going to go back and go over some aspects of it in a little bit more detail. What we're talking about is nutrients, which is not the only aspect of water quality, of course. So we're not talking about public health and coliforms here. We're talking about nutrients. So I see Mike Taylor. I'm sorry, Mike, no public health here. We are all familiar with, for a long time, I think, with the intensification that's occurred, particularly in the central North Island, the Rotorua, Taupo, and the Waikato. Since the war, the cobalt deficiency, the land boom. What we were not aware of, although there were hints until more recently, is the groundwater lags. Lord Taylor and others had started to age some of the groundwater around Rotorua when I first started working there, but it's only in the last 10 or 15 years that science has become quite mature. And it's not only central North Island, of course, it's in the South Island as well, and GNS have done a lot more work on aging those groundwaters using bond tritium. And then the other aspect of it, I think, which has confirmed what we've been suspecting for a long while, is the National Water Quality Monitoring Network, which has shown some quite alarming trends, particularly in nitrogen concentrations in New Zealand waterways. And then, of course, the public are demanding improved water quality. The three examples are the ones that I'm most familiar with in the North Island. There are other examples from the South Island. I'm going to talk in a little bit more detail about Taupo and Rutherford, but the Waikato, with the Waikato Independent Scoping Study, is also one of those. Quite clear evidence of increasing nutrients, many of them associated with farmland, and deteriorating water quality. And the science, clear indications of the need to reduce nutrient emissions, particularly from diffuse sources. Point sources we know are reasonably well controlled by the RMA, but agricultural sources are not quite so well controlled. And part of that is scientific. Obviously, in a catchment, there are numerous emitters, and the emissions are highly variable. I mean, we know that forest emits less than sheep and beef, emits less than dairy, emits less than arable. But even within dairy farms, there is a huge variation in nitrogen emissions, depending on soils and the way in which it's farmed, and the mitigations that have been put in place. And of course, these things are scattered throughout the catchment. And the effects tend to be off-site and cumulative, so that an individual farmer doesn't necessarily see the adverse effects that his or her nutrient emissions are causing. And those nutrients get delivered by different pathways at different rates. Groundwater takes a long time to get into the lake, surface water much quicker. And along those routes there are transformations. So nitrogen is changing from nitrate into other forms and then back again. Some of it is being stored in long-term stores. Some of it is being removed completely. In the nitrogen case, denitrification, a permanent loss of nitrogen, one of the very few permanent losses in the system. So we all want good water quality, but we also want to increase agricultural earnings. A lot of people see that reduction of nutrients is too expensive, and I'd like to just dwell on that a little bit, because I think it's got a myth. There are plenty of people in the room who will be talking about the toolbox of mitigation measures that have the potential to significantly reduce the adverse effects of agriculture. Not without limit, but there certainly is a toolbox out there that is being used by many farmers to reduce their footprint. And as Hugh has already alluded, in that sort of environment, the potential for trading is that it minimises total costs, because it enables those who can mitigate using the toolbox at least cost will do so. So what science do we need to underpin this nutrient trading? The things I put there in yellow are science related, and those that are up there are perhaps more management. So who will, what's what I wanted to do, who will trade? Clearly we're talking farmers, and that most of the point source discharges will be in what Hughes called the unmanageable load. What he really means is being handled outside the trading system. The initial allocation problem here, Susie's alluded to, and others, how do you actually go about trading? That'll be talked about this afternoon. And I think Hugh and Susie used the word compliance and enforcement rather than cheating. But I'm just going to talk a little bit more about what we trade and the total amount. Clearly what we trade has got to be farm emissions. There was some debate though, because in many cases what we're after is a reduction in lake load. But we'll come back to the relationship between farm emissions and lake load in a minute. But having said we're going to manage we're going to trade farm emissions, we know from a water quality perspective that daily, weekly, annual, or even decadal emissions, which of them are we going to trade? And it turns out that debate is a pretty short one, because there is no way in which we can measure emissions from every farm. We have to predict them or model them in some way. Overseer has been mentioned. It's the model of choice, and it's a long-term average model which works at an annual scale. So sort of debate over. We're going to manage annual emissions, and we're going to trade annual emissions. Works fine in Rotorua and Taupo. I'm just starting to do some work now on rivers in the Rua-Taniwha, and certainly people working in estuaries are going to have to struggle with this a little bit more, because their water quality is very strongly event nominated. Some are low flows, periphyton blooms on stones, and the question there is whether annual loads are going to be the thing to manage. Total amount traded, and here I want to draw a contrast between the two central North Island lakes that we've worked on, because they've adopted completely different approaches to deciding what's going to be traded. In Taupo, the goal was water quality as it is now, no worse than it was now. And after much discussion amongst the scientists, that goal can be achieved with a 20% reduction in emissions from pastoral agriculture in that catchment. Rotorua was slightly different. Same sort of goal. We want a better Lake Rotorua, and the goal was set to restore lake water quality to what it was in the early 60s. But look what the target was set in terms of lake load: 435 tonnes a year of nitrogen reaching the lake. And currently it's about 750. You see those numbers from Hugh already. So in this case, it's a 20% reduction in farm emissions. And this one is a lake load of 435. So what's the difference then between those two approaches? And to illustrate, we'll talk about a subcatchment of Lake Taupo called the Tutai, where there has been a long-term multi-agency study that has involved several people in this room. There are two. Used to be Landcorp farms on that in that catchment. Lincoln Ventures have looked at a very small area at the top of the catchment. Been looking at groundwater using their SPIDEA. Ag Research have done a lot of work on looking at the history of land use in the catchment. GNS Science have dated the groundwater. NIWA has done quite a lot of work looking at nutrient removal in the wetlands and the catchment